I'm Russ Briall with the Shroud of Student Education Project, and welcome to the Shroud Report. Now, today my guest is Pete Schumacher. Now, Pete, thank you for coming.
My pleasure, Russ. Nice to be here.
Now, you are a specialist in images.
Well, image processing, remote sensing, collection of images. We try to help people solve problems with imagery, from satellites or video cameras or various kinds of sensors.
Now, you've been involved in this kind of work for years and years.
Oh, a long time. I started in 1972 at a place called Interpretation Systems Incorporated in Lawrence, Kansas, and have been in the field ever since.
Okay. Now, your first encounter, and the reason that you're here on the Shroud Report, is with a special computer that is known as a VP8 image analyzer.
That's correct.
And maybe you can explain what that computer does and did. And
be glad to. Basically, the VP8 image analyzer was an analog computer, not like the digital computers we have now today. And to that extent, it was what we might call a dumb computer. It did a few simple processes, and if you put a video image into the machine, it would automatically process the image in a particular way and then make the output instantaneously. So we didn't do an analog to digital conversion or work with it with a laptop computer like we would today, and of course we could do more sophisticated things today, but the beauty of the VP8 image analyzer was its simplicity and its speed.
so in other words, the information that you got from it is what it is. You couldn't really manipulate it or make it say something that wasn't there.
That's correct. Basically, what you put in created whatever came out.
Okay.
The VP8 image analyzer,
I think you have a picture right here. Okay.
We have a unit that was used to do all kinds of interesting photography with Landsat satellite photographs and various aerial photographs as well. And we were trying to look at the Earth's resources with these to determine the health of soils and the condition of crops and where riparian zones were and locate water resources and things of that nature. We also found that there was a particular display that this unit had that was very good for tracking linear features in the Earth's surface. And this would be like a fault line, for example. And of course, we're all very interested in where are the fault lines because we're worried about earthquakes.
Right.
So one of the things that we did was we followed these linear features using a feature of this particular instrument, which was called the isometric display.
Okay.
And basically the way it worked, if we took a look at our globe from space, and this photo here is courtesy of NASA, we would get a picture then, we would think, that is round.
Right.
And maybe looks like a sphere, like a basketball, because we know from Columbus that that's what should be. And the way the VP8 image analyzer works is that it would scan a horizontal TV line in the picture, which is what we see in this slide.
Right.
And bright things went up and dark things went down. And if it was some shade of gray in between, then it would be at an elevation in between.
Okay.
If we took all of the lines in the picture and we looked at them all together at the same time and tilted them back, we would get what is called an isometric display.
So how many lines would be in this picture here?
Well, there are 480 horizontal lines that are visible in this scene.
Okay.
And so there are 400 lines that go from left to right across your screen, basically. And there are, of course, then features across each one of those lines that represent brightness changes.
Right.
Up being bright, dark being down.
And what we're looking at here is the cloud cover from that picture we saw from space.
That is correct. And the net result, of course, is not a sphere, not a basketball.
No.
It's not a three-dimensional display.
Because the photograph itself is not three-dimensional, correct?
Well, the photograph itself is only two-dimensional. That is correct.
Right.
And brightness values in this image have nothing to do with elevation.
I see.
If we thought for a moment about maybe a bright white peak on a mountain where it's snow-covered, and then maybe there was a rock sitting on top of that mountain, then where the mountain was bright white, it would be up. but where the black rock was, it would be down.
In terms of that isometric line, that a graph, where it was white,
correct.
the line would go up. Where it was dark, it would go down.
And so if I came up for the nice white snow-capped peak,
right,
and came to where the rock was that was actually above the snow, the rock being darker than the snow would look like a hole in the snow instead of like it was sitting on top.
I see. So even though it's higher, it looks lower.
That is correct.
Okay.
And that's a simple way to state that with a VP8 image analyzer, and as we see in the slide picture, we don't get a three-dimensional result.
Okay.
Brightness doesn't have anything to do with dimensionality, height or depth.
I see. Okay. Okay.
But when we put a shroud slide, say for example the face image,
right,
into a VP8 image analyzer, the result we get is quite a bit different.
So there's no distortion. What I'm seeing here is an image which appears to be three-dimensional.
That's right. Where the nose ramps up on the face, like my nose ramps up if I were laying down.
Right.
And where the forehead rounds off and things are in the proper perspective,
They're in their
generally
proper
speaking.
So because it's not based on light or brightness.
There's evidently
it's not
something
based
on the shroud that causes the brightness values in the shroud to produce a three-dimensional response when we scan it with a VP8 image analyzer.
Okay. Okay.
I think probably the best way to illustrate this, I'm going to back up one slide, and we're going to look here at the shroud image. On the left in this image, we see the photographic positive. That's the way the shroud looks if we take a picture of it.
Right.
When we develop the photographic negative, however, that's the picture we see on the right.
Mm-hmm.
And kind of like Secundo Pia, when he took his first photographs, we found out something rather startling about the Shroud of Turin image. Secundo Pia noticed that the shroud image looked easier to see and had more contrast and more detail in the photographic negative form, and he called it a photographic negative.
Right.
Well, when we scan it with the VP8 image analyzer, we get a three-dimensional response back.
And you even see more detail here than you do in what you can see visually on the cloth itself.
Well, we see form.
Mm-hmm.
We see something we don't see when we look at the cloth. The cloth is a two-dimensional image. The photograph that we're taking this image from is a two-dimensional image. But the grayscale information is causing a three-dimensional result.
So it's the grayscale information, the
actual data on the shroud.
The data, you called, I remember talking to you before, and you called it a spatial database.
The shroud itself is basically a spatial database.
And
in other words, it has a form, a two-dimensional form, and within that form it has image information and stain information and fold mark information and all kinds of other information. And when we have a two-dimensional space that contains particular information that may be physically located, we call that a spatial database.
Okay.
So the shroud itself is a spatial database.
Like a topographical map.
More or less like a topographical map. In this case, because now we have elevation information as well as bright and dark or red or other colors or fold marks.
And what creates that spatial information then is what you call the grayscale, meaning I've heard it described that the reason that this phenomenon seems to occur with the shroud, this three-dimensionality, if you will, is that it appears that the closer the cloth was to the body, the darker the image.
Well, now that's one theory.
Okay.
So we now get into what we call theories.
Okay,
right?
okay.
And so one scientist might pose that the reason that the information has a three-dimensional characteristic is because its proximity, its closeness to the body that was inside of it. Another person might say, well, I think it was some sort of thermal radiation or some sort of electromagnetic radiation or some other type of energy. And we don't know that. We don't know what caused the image. We only know the result of the processing.
We just know the results. We just know that for some reason the shroud image contains data that indicates distance information, height, and somehow related to the grayscale information.
That's correct. And we don't know why.
Wow.
And we don't know exactly how. Now, it's true that this occurs on both the front and back of the image. If I take a picture of a human being, as we're showing here, and I process it through a VP8 image analyzer, we can see that it no longer has a three-dimensional characteristic. The shadow of the person's nose is cast to the right-hand side of the nose, and therefore it looks like the nose has a large dip or groove in it. Also, because the flesh tones are fairly uniform, and the reflectance then of the flesh tones are pretty much the same, they all wind up at about the same altitude, I should say, the same height.
Right.
The eyebrows in this case look like grooves because the eyebrows of this person happen to be darker than his skin tone.
And because they were darkened, then like on that graph that you showed, they go down.
That is correct.
Okay.
And so when we normally process a normal photograph, we don't get a three-dimensional result. It doesn't happen. It only happens when we process an image from the Shroud of Turin. If we look at artworks from back in the 1600s, for example, this artwork was made, we find out that they don't make a three-dimensional result.
Right.
The results are not anywhere near the same as taking a photograph image of the Shroud and processing it, or processing the Shroud photographs in a positive or negative form.
Right.
So it's only with the Shroud images that we get this reaction, shall we say, to a three-dimensional result. And the result occurs over the entire front and back of the image. And in this slide, this is a positive to negative of the front of the body on the Shroud of Turin. If we process that image, we get a three-dimensional response. And in the upper part of this picture, you can see that the arms have a three-dimensionality characteristic to them. The face, of course, as we saw before. But look at the legs as well. The legs are rounded, and they come up to the knees, and we see a contour there, or a shape, an elevation change, that is particularly unique to the Shroud of Turin. If we look on the back side of the image, we can see a generally three-dimensional characteristic as well, where we can see the shaping, basically, of the back of the shoulder blades, the back of the head, and so on.
What are those lines that seem to traverse?
The large lines that seem to be prominent in the picture, unfortunately, are from the burn marks from when the Shroud was in a fire in about 1532. And we know what the cause of those marks are, so they're not part of the image, and it's difficult for us to ignore those when we're looking at the Shroud of Turin image, but they're not really part of the image information. They're part of something else that's an artifact of the fire in 1532, so we have to learn to ignore those.
Right. This is fascinating stuff. I think we're going to take a break right here. We're going to be back with more of this on the Shroud Report in just a minute. Hi, I'm Russ Brialt, and welcome back to the Shroud Report. And today my guest is Pete Schumacher. And Pete, you are an image specialist.
Image analyzing and remote sensing.
And we've been talking about this curious phenomenon of the Shroud, this kind of 3D aspect of it, of the image, and you know, I think what most people that I talk to find interesting about the Shroud is its mystery. It's just this phenomenal mystery, and it just seems every time I talk to someone on the Shroud Report, the mystery just gets more profound.
I think we are learning more things as our knowledge advances as a society, and I think we had a couple of major jumps in understanding about the Shroud of Turin when Secundo Pia developed his photographs in 1898. And I think we had another big jump